All right. This is a quick review for chapter 5, work, energy, and power. Okay. What do you need to know in this chapter? First of all those equations. Work is equal to force times displacement. Kinetic energy is half times mass times velocity square. Remember, the velocity alone is squared, not the mass. Okay, and then we have change in gravitational potential energy, that is mass times gravity times the change in the height. Now, elastic potential energy is half kx square, where k is the force constant of the spring or stretchable material, and x is the extension. Okay, x is the extension. Then we've gone through power as work over time or energy over time. We also went through power as force times velocity. So you must be familiar with all these equations. Now, work is force times displacement. Force is measured in newtons, displacement is measured in meters. So the unit of work is Newton meter or joule. Joule is the same as Newton meter. Kinetic energy is also measured in joules. Change in potential energy is also measured in joules. Elastic potential energy is also measured in joules. Power is measured in watts. Work is measured in joules again, so watts is joules per second. Watts is joules per second. Power in watts is force times velocity. Velocity should be in meters per second, not in any other unit. That being said, you should understand the main idea of work. Work is force times displacement. So if you have an object and you apply a force F and you move it through a displacement D, then the amount of work done is Fd. But if the force is applied in the backward direction and the object is sliding in the forward direction, then the work done is negative. So when is the work done negative? When the force is opposite to the displacement. If the force is perpendicular to the displacement, so when the object is going sideways but the force is acting that way, then work done is 0. So if I'm going to take a book and move it horizontally, I'm not doing any work on the book. If I'm just going to carry it horizontally, I'm not doing any work. Only when I lift it upward or downward, then yes, there is work involved. If the force is at an angle, then the work done is Fd cosine theta, because only the cosine component of this force will do the work. It also can be for pushing. If you push an object at an angle theta, same equation applies. Okay. Now, going back to this equation, kinetic energy must be in joules. Mass must be in kilograms. Now, if mass is given in grams, you have to change it to kilograms. And V is in meters per second. What if I tell you that if an object is moving with a certain speed, and if the mass of the object is doubled and the velocity is also doubled, what will happen to the new kinetic energy? So the new kinetic energy is half times mass is doubled, so make it 2m. Velocity is doubled, so take it 2v squared. So if you process this, you get, leave alone the half there, 2 is come out, and then 2 square is 4v squared. Now if you bring the half and m and v square out, you can see the numbers 2 and 4 sticking out. So you have half times mv squared times 8. So the new kinetic energy is 8 times the old kinetic energy. Okay, so you should be able to see what you should be able to compare and see what happens to the kinetic energy in case of such changes. Potential energy also measured in joules. Mass again must be in kilograms. G is 9.8. Height should be in meters. So if you're given height in centimeters, you should change it to meters. Elastic potential energy is in joules, and half kx squared. K is a force constant and it has a unit of Newton per meter. Extension must be in meters. Now if extension is given to you in centimeters, then you should change it to meters before using it here. Okay, that is to find the elastic potential energy. For example, if you're told that an object that is here is going to fall from there to here. Okay, so what is exactly happening? Over here the object has GPE, and over here the GPE is 0. Over here the object's kinetic energy is 0 because he just dropped it, and over here the kinetic energy is something. Now what you should understand is the total of these two here should be equal to the total of these two here because the total energy is conserved. Because the total energy is conserved, the sum of these two should be equal to the sum of this. Now we don't have to worry about these two, that because they are zeros. So that means the GPE here should be equal to the KE. Now GPE is mg times the height. KE is half mv squared. So mass does not matter. So whatever you drop, they're going to come down at the same speed. So you should be able to solve problems using this equation. Like if I give you the height of fall, can you find out how fast it's going to land here? Substitute. Height is given, g is given, this is 2, get the v. So you should be able to work this out by multiplying throughout by 2. So if you multiply throughout by 2, you can single out the v square and you find the v from there. Okay. Similarly, you should be able to work with even this equation, half mv squared. If I give you the kinetic energy, and I give the mass, can you find the v squared and v? If I give the kinetic energy and the v, can you find the mass? If I give the mass and the v, can you find the kinetic energy? So all these things, this is how the fluctuations, the questions are going to be seen. I'm not asking very, elaborate, difficult to problems in this test. They're all straightforward. You should be able to benefit from this conceptual test. It is a multiple choice test, but you need to show work for a specific number of questions. So you must show the work very clearly. Whatever little work you do, don't put everything in the calculator. You must show it on paper as to what steps you have taken in order to get to the final answer. If you just say, I did it on the calculator and here's the answer, I won't take it. Okay, so those are the questions where you need to show work. Now, not all questions you need to show work for, only specific ones I will let you know. Other than that, what you should know other than that is, like for example, if there's a car, there's a driving force making the car go forward. So the driving force is doing positive work. But there's a drag force here, like friction. The drag force is in the opposite direction to the displacement. So when you have a drag force in the opposite direction, this thing is doing negative work. While this one is doing positive work, this is doing negative work. But since the object is still moving forward, definitely the positive work is more than the negative work. So you should be able to understand, how to work it out. If I give you a driving force and all that, how do you find the net work done? Okay. The other variations, the questions, let's see. Power. Power is work over time, and work is any of this. Energy is any of these. So imagine if there's a stone here, and the stone has to be taken up to here. And if I give you a certain height, can you find out how much work is required to take the stone over there? All you do is, the stone is going to gain GPE, that means mgh. So if I give the mass of the stone, and if I give the gravity, multiply by height, that will give you the potential energy. So how much potential energy did this gain? That much work you have put in. So that is the work. And if I tell you the time it takes to go from here to here, the stone is taken from here to here in 5 seconds, then you know the time. If you divide this energy with the time, that's basically going to give you the power. And the power will be in watts. And in this equation is, if I give you the force, the driving force, and if you are told that it's moving with a certain velocity, how can you find the power? Now remember, when you're using these equations, power must be in watts. Okay? The work must be in joules, and the time will be in seconds. Now if the power is given in some other unit like kilowatts or megawatts, you have to change it to watts before using it. And if you do so, you'll get the time. All right? So for example, if there is a pump has a power of 5 kilowatts. Now if this pump is actually used to pump water to a height, and this is the amount of energy that is used by the pump. So in what time did this pump do the work? So what you do is, power is energy over time. If you cross multiply, you get power times time is energy. So what is time? It's energy over power. So you should be able to divide it and see how much time it takes, so 20,000 divided by, now 5 kilowatt is 5,000 watts. So it will be 20,000 divided by 5,000, that will be 4 seconds. So you should be able to work problems of that kind. So as I said earlier, this test is not going to be testing you with the difficult questions. They're all straightforward questions. All you have to know is concepts of all these 3 terms and the conservation of energy. So if energy is lost, like when something goes down, is losing energy, so kinetic energy is gained. And that's the equation that you deal with. So make sure you're familiar with all these things. Bring your calculator and do your calculations properly, and don't make a mistake, and show work in a legible fashion so that I can check your answers faster and give you better grades. All right, so this is pretty much it. Apart from this, if I'm you, I will definitely go back to the homework questions. And because I said tough questions are not required, look for some of the easy questions in the homework exercises that you've done and try and see how it is done. Okay, and practice on it. So if you do take care of all these things, you should do this test pretty well. So all the best for it.